Hello my dear students, this is Atif Ahmed, your physics teacher, and today we are going to discuss about refrigerator. In this video lecture, you will learn the basic working principle of refrigerator, how cooling process is performed inside a refrigerator and how a heat pump works. Okay, so let's start with the basic definition of refrigerator. It is simply a device that extract heat from a colder region and send it into the hotter region. It have the five major components. Number one, refrigerant. Number two, compressor. Number three, expansion valve. Number four, condenser coil. And number five, evaporator coil. Refrigerant is the main working substance in this system, and it is a gas known as freon gas. Okay, and the second very important component is compressor. Its function is to perform work on the refrigerant or working substance. And the next component is expansion valve, as it is clear from its name that it is used to expand the gases to decrease their temperature. And in the last there are two coils, condenser coil and evaporator coil. Condenser coil is present outside the refrigerator box and its function is to emit heat in the surrounding. And the next one is evaporator coil, that is present inside the box of the refrigerator, and its function is to extract heat from this region. Okay, now we are going to discuss its diagram. As you can see that its simplest diagram, this is the box of the refrigerator, and evaporator coil is present inside this box, and all the other components, compressor, condenser coil and expansion valve, are present outside the box. Okay, so that condenser coil is basically located at the back side of the refrigerator. Okay, now we are coming toward the working principle. My dear students, everybody knows that the heat flow from a hot body to cold body, but you can also travel the heat from a cold region to hot region by doing some work. For example, the object naturally travel from a high position to low position, from high to low, but you can also move them from a low position to high position against the natural law. But in this case, you have to do some work. You have to apply the force and displace it in the vertical direction. In this way, you will do some work and the body will be shifted from a lower position to higher position. Same is the case here. Heat naturally can travel from a hot body to cold body, but you can also travel it from cold to hot body by doing some work, and that is the basic principle of refrigerator, in which we do some work and transfer heat from a cold body to hot body. Okay, it is completely opposite to the heat engine. In the heat engine, we have the two main parts, high temperature reservoir and low temperature reservoir. So heat will travel naturally from a hot body to cold body, and that heat will perform some work. You will obtain some work and the remaining heat will be sent into the sink or lower temperature reservoir. But in this case, you have to do some work and heat will be shifted from a lower temperature reservoir to high temperature reservoir. Okay, so when you apply some work, like you have applied the 1 joule work, so let me mention 1 joule work. You have applied the 1 joule work and it will extract the heat from this low temperature reservoir, that is Q2. Let's say this is 5 joule heat. Okay, so 6 joule heat will be sent into the high temperature reservoir. How? 1 joule is the work and 5 joule is the heat. So 5 joule plus 1 joule will be total 6 joule, and that will be sent into the hotter region, that is high temperature reservoir. So simply the working principle is that we have to apply some work. The heat will travel from a low temperature reservoir to high temperature reservoir, or simply from a cold region into the hot region. Okay, so this system is also used as a heat pump. Now remember that if you are going to use it as a refrigerator, then you have to enclose the evaporator coil inside a closed box. So there will be decrease in temperature inside this box. Okay, how? The process is that simply the heat will be taken from this coil or this region and transferred to this coil, condenser coil, and from this coil it will be transferred into the surrounding. So there will be some decrease in the temperature. So remember that when you are going to use it as a refrigerator, you have to enclose the evaporator coil in a closed box. But when you have to use it as a heat pump. Then you have to close the condenser coil inside a closed box, and this evaporator coil will be present outside of the box. In this way, it will extract heat from the surrounding and it will pump into the this closed box. So temperature of this cold box will start increasing and we are further pumping a heat into this closed box. So in this way, you can also use this setup as a heat pump. Okay, it is clear? Now we are moving toward the explanation of this working principle. So we will learn how it works as a refrigerator. Okay, in this case, the main working substance, that is a freon gas or refrigerant, perform a work in the cyclic process, but this is opposite to the heat engine. As I have told that in the heat engine, the heat will flow from a hot body to cold body and do some work. It will provide some work. Remaining heat will be sent into the sink or low temperature reservoir. But in this case, you have to apply the work and heat will be transferred oppositely from a low temperature reservoir to high temperature reservoir. Okay, so what will happen? Simply, this evaporator coil of the refrigerator will extract some heat Q2 from this region. For example, you have placed an apple inside this box. This apple was initially at the surrounding temperature. It was a high temperature you have placed there, and that heat of the apple present inside the apple will be extracted by this evaporator coil, and that will be thrown out by using this condenser coil into the surrounding. Okay, but to perform this function, you have to do some work, because without work you cannot travel the heat from a cold region into the hotter region. As it is clear that the region inside the refrigerator is the colder region and the region outside the refrigerator is a hotter region. Okay, so the working substance is basically a freon gas that will perform a cyclic process, and and the main part is that will extract the heat from this region by using the evaporator coil, and that will send the heat outside the condenser coil into the surrounding. Okay, and in this case we have to do some work. I have mentioned all these 3 points here. Okay, so that is simply the explanation of this working principle. Now we are coming toward the main process of cooling. There are 5 main points. Remember that how it works. There is a body compressor. Compressor will compress the gas, freon gas. By compressing the gas, its temperature will increase up to 90 degrees centigrade and its pressure will also increase. Okay, then it is allowed to pass through the condenser coil. When it is passed through the condenser coil, the heat will be taken out by the surrounding. The heat will be shifted toward the surrounding. That heat is Q1. Okay, so when the heat will be removed from this gas, its temperature will decrease and temperature will be up to 40 degrees centigrade. That was initially 90 degrees centigrade. Okay, then to cool it further, it is allowed to pass through an expansion valve. When this freon gas will pass through this expansion valve, it will further cool down and its temperature decrease to minus 16 degrees centigrade, minus 16 degrees centigrade, and it will be completely converted into the liquid. So now this liquid freon will pass through this coil called evaporator coil, and the freon liquid present inside this coil is at minus 16 degrees centigrade. So the apple present inside this box have a temperature maybe 5 degree, 10 degree or 7 degree, and the liquid present inside this coil have minus 16 degree. So naturally heat travel from a hot body to cold body. So heat will be absorbed from the apple and that will be absorbed by this refrigerant or the freon liquid present inside this evaporator coil. So when this evaporator coil absorbs the heat of the apple, its temperature increases and again it will convert from the liquid state into the gaseous state, and again it will move toward the compressor. Compressor will again compress it and again its temperature will increase and it will send into the condenser coil, and the heat will be taken by the surrounding from this condenser coil, and again its temperature will decrease. Then it will be passed through the expansion valve and further its temperature will be minus 16. So in this way this process will continue. Okay, so that is the basic working of the refrigerator. I have mentioned all of these in the points, and you can also write this point in the paper in the same way. Okay, now we are coming toward the performance of this refrigerator and as a heat pump. Whenever you are going to check the performance or efficiency of a device, you simply take the ratio between output and input. Okay, so if we consider the case of refrigerator, what will be the efficiency or what will be the performance of this refrigerator? That will be simply a ratio between output and input. And remember that in the case of refrigerator, what is the output required? The output required is to produce cooling in this box. And how you will produce the cooling? By extracting the heat Q2 from this region. So if you extract the more heat from this region, more output will be. Okay, so output is simply in the case of refrigerator, that is Q2, and the input, that was the work performed by the compressor. So without giving the input, you cannot get the output. So input is simply the work, and the output in case of refrigerator is the heat Q2 that was extracted from this region. Okay, so it is a ratio between Q2 and the work. We can say that simply the ratio between output and input. The output is Q2, the input is W. Okay, so we have to place the value of W, that is Q1 minus Q2, as I have told that if 1 joule work is performed, let's say 5 joule heat is removed from this low temperature reservoir, but 6 joule heat will be shifted into the high temperature reservoir. The difference between these two heat, Q1 and Q2, 6 joule minus 5 joule is equals to 1 joule. So Q1 minus Q2 is equals to work. That's why W is equals to Q1 minus Q2. So put the value of W, Q1 minus Q2, that is the basic formula of performance, coefficient of performance, or simply we say that CP cooling. Okay, and if you want to write this formula in the form of temperature, so you can also replace Q by simply T, because we know that the Q has the direct relation with the temperature. Heat has a direct relation with the temperature. So we can replace simply Q by T. So that will be T2 by T1 minus T2. That is the CP cooling. Okay, but in case of heat pump, what will be the efficiency or what will be the performance of this device? Okay, remember that in case of heat pump, the heat pump will transfer some heat Q1 into the closed box and increase the temperature of this box. So in this case, the output is basically the Q1. If it is pushing the more heat into this box, it means that the more output is. Okay, so Q1 is the output in the case of heat pump. And what is the input? The work. Because without doing work, you cannot transfer the heat from this region to this region. Okay, so in this case, the work, the required output is the Q1 and their work is the input. Okay, so same the ratio between output and input, that is output Q1 and input W. Put the value of W, that is Q1 minus Q2, and in this formula you will get that CP heating is equals to Q1 divided by Q1 minus Q2. Okay, now if we want to write it in the case of temperature, then we know that heat is directly proportional to the temperature, so we can replace Q by T. So CP heating is equals to T1 by T1 minus T2.